Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, properties of set operations. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 10th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 4 parts, so leave a like, smash subscribe, and let's get started. So today we're going to be talking about properties of set operations. More specifically, we're going to be looking at properties of unions, intersections, difference of sets, and complements. However, unlike my usual videos, we're not going to have a lot of different examples. What we're going to be doing is we're going to be going over the different properties, we're going to talk briefly about them, and for the more confusing ones, we'll do something like a Venn diagram to illustrate what they look like. Now, a little disclaimer. This video is going to be done under the assumption that you have a good understanding of each of those set operations. However, if you need a refresher on your unions or intersections, no worries. I have a video that you can find right up here. Click that and make sure you understand those 2 set operations before you start diving into their properties. Now that we've gotten the bookkeeping out the way, let's look into our properties of unions. Now, I wanted to start with the properties of unions only because, in my personal opinion, the unions are going to be way easier to understand than the rest. And that's simply because of the nature of a union. So let's start with our first property here. A union B is going to be equal to B union A. Now, this is going to be kind of easy if you think about what a union is, the property of a union itself. Well, a union is going to say, I want everything in one set and everything in another set. You're going to be looking at everything in those 2 sets. So it doesn't really matter the order because you're taking everything from both sets. So A union B, it doesn't matter if you took A first or B first because you're going to grab everything. So whenever you're doing a union, it doesn't matter which set comes first. You can do A union B or B union A, it's the same thing. Let's move on to our second property. Here we have, in parentheses, A union B, union C. And that's going to be equal to A union B, in parentheses, B union C. And this just tells us that it doesn't really matter what type of grouping you do. If you think about it, that makes sense. Because a union doesn't really care. You're going to grab everything. So it doesn't matter the order. A union B, if you're grabbing everything in A and B and then union it to C, it doesn't matter if you do B union C first because you're still going to grab everything and then you're going to union A to it. You're just going to end up with everything in A, B, and C. Now you can think of it like this. Let's say it's you and 2 other friends, and you're just trying to pool together all the money you guys have on you at this moment. It doesn't matter if you take out your money first, or friend A take out his money first, or friend B takes out her money first. It doesn't really matter. You're gonna take all you guys' money and pool it all together. So if it's you and friend A, or friend A and friend B, it doesn't matter. You're gonna end up pooling all your money together anyway at the end of the story. So when you have unions, your grouping, it doesn't really matter. The end result is the same. You can shift your parentheses wherever you want. Let's move on to our third property. It says A union the empty set is going to equal A. Now if you think about this, if you break it down, it makes sense. The empty set has nothing in it. A, well, it's A. So when you union, take everything in A and then take everything in the empty set, which has nothing in it, well, what are you going to be left with? You're not adding anything to this A, so you're going to be left with A. Because the empty set is empty, you're not going to be adding anything to whatever set is here. It doesn't matter what it is. So you're always going to be left with just the set you started with whenever you're going to union the empty set. Let's move on to our fourth property. This says A union A is going to equal A. Now, once again, think about what the union means. This is going to make sense in the same way that this made sense. This, you didn't add anything new to A because there wasn't anything in there. This, you're not going to add anything new to A only because everything that's already in this A is in this A. You're not adding anything new because it's the same exact set. So the union is going to take everything in both sets. Since this A is the same as that A, you're not adding anything else. You're going to be left with A. Nothing is added, nothing is taken away, so you're just left with the original set A. And of course, at any time, if any of this does confuse you and you want me to go into more depth, please put it in the comment box. I can make another follow-up video or even just address you directly in the comments if that's going to be easier for you. All right, let's look at our last property. This is the universal set. This is our big set that contains everything, contains the whole universe if you want to think about it that way. This big set, universal set, union A, is going to equal that universal set. Now, what does this mean? This means that everything, the set that contains everything, including this set A, when you union those two, you're going to get the set that contains everything. Now, that may seem a bit abstract, but just think about it this way. This big set already has A in it. So just like you didn't add anything new to this because A was exactly the same A, this is a subset of the universal set. The universal set has all of these sets, so this A is going to be a subset of that universal set. Therefore, you're not adding anything new to that universal set. So when you union that, you're going to be left with that same universal set. So these last three properties are all telling you a very similar story. In this first one, you're not adding anything new to A because there's nothing in here. In our second one, you're not adding anything new to A because everything that's already in this A is here already. It already exists because they're exactly the same set. And in our last one, you're not adding anything new to the universal set because A is inside, it's contained. All the elements of A are already going to be in this universal set. So these are going to be the properties of unions. Let's move on to the properties of intersections now. So now we're going to be jumping into the properties of intersections. And our first one says A intersect B is going to be the same as B intersect A. Now what this tells us is it doesn't matter in which order you do the intersection. Remember, the same thing is going to be true for your unions. If you're going to say what's in common with two sets, it doesn't matter which order you look at them. You're still going to find what's in common with both of them. Changing the order of your two sets is not going to suddenly add or remove extra elements. What's in common is going to be what's in common. It doesn't matter the order. And by extension, your second property, in parentheses, A intersection B intersect C is going to be the same as A intersection in parentheses, B intersect C. And this is going to be because of the same exact reason. It doesn't matter the order. So you can shift your parentheses however you want. Ultimately, at the end of the day, you're trying to find what's in common with all three sets. So if you remember that example I gave for the union in pretty much this similar boat, where you have you and two other friends trying to pull together all your money. Well, now let's say you want to pull together all the $5 bills that you had. So it doesn't matter what other money you have. You can have some singles, 10s, 20s, 100s. It doesn't matter. You want to pull together all the $5 bills that you have. So now you see, you and your first friend, friend A, it doesn't matter if you pull together all of your $5 bills and then check with friend B, or if friend A and friend B get together their $5 bills and then check with you. It is not going to add or remove any $5 bills. You're going to pull the same amount of $5 bills from each of you. So the order does not matter when you're doing the intersection. Let's move on to our third one here. This says the empty set intersect A is going to equal the empty set. Now, why is that true? Well, if you think about it, this has nothing. This has something in it. We assume it has something in there, but this has nothing. And you're trying to find what's in common with both of these sets. Nothing and potentially something. What do they have in common? Nothing. So that's why you are left with this empty set. If you try to intersect empty set with anything, you're always going to get the empty set because that has nothing in it. It cannot have anything in common with any set. Let's move on to our fourth one. We have the universal set intersect A is going to equal that set A. Now this looks very familiar to what we did for unions, however, it's a little bit different. It's still operating under the fact that A is a subset of this universal set, but when you try to find the intersection, remember, A is a subset, meaning it's a smaller set. Everything in A is going to be in the universal set, but not everything in the universal set is going to be in A. So when you're trying to find what's in common, well, if this is all contained in this universal set, then what's in common between them is that entire set A. This lets us know that if you have an intersection between a set and its subset, you're going to always end up with that smaller subset as the end result. Let's move on to our fifth one. The intersection between A and itself. Well, once again, everything in A is going to be in A. So you're going to be left with just A. Pretty self-explanatory. Now this last one. This may be a little confusing when you look at it at first, but let's try to break it down. We have A intersect, and in parentheses, B union C. This is a little bit different from up here because you have both intersect and union here. And it's going to equal A intersect B union, so in parentheses, union A intersect C. So what is this telling us? It lets us know that we can actually distribute this intersection if we have a union like this. That means each one of these sets gets that same intersection with this set out here. That's our end result. Now let's do a Venn diagram so you can see what I mean by this. So let's say we have our Venn diagram like this, where we have set A, B, and C. And we're trying to find A intersect the union of B and C. Well, B and C, the union, is going to be everything, right? And then we're going to figure out what intersects A. Well, the only thing that comes in contact with A from both of these sets together is going to be this right here. This is going to be what's in common with A and the union of these sets. This is not an A, this is not an A, this is not an A, so this is the only thing that's left. Now, if we take a look at this, take a step back and take a look at this, you'll notice that individually, A intersect B. That's going to be this right here, right? This right here. And we see we're coloring the same thing that we already colored. And we're going to union, so we're going to take that and look at what's in A intersect C. Now this C in that A, that's going to be this, right? This right here. So when you put all of those together, you get this. So it shows you that if you have this intersection and you have this union like this, you can distribute this intersection to each of those sets and then make sure you join them together with that same union. Try it out with actual sets, with numbers or letters, whatever you want to do, and see how it works out. But here's your Venn diagram to illustrate what this looks like. Now we're going to move on to difference of sets. So for the difference of sets, we're going to do something a little different from the previous ones. Instead of looking at properties of the difference of sets, we're going to be looking at one big observation. I'll break it up into two smaller observations, but one big observation that we'll talk about here. Now, if you need a refresher on the difference of sets, no worries. I have a video you can find right up here on the difference of sets. Make sure you have a good understanding of that before you jump into this portion here. So let's look at this very first part. This says A minus B is not going to be equal to B minus A. Now think about what the difference of set means. A minus B tells us that we want everything that's in A but not in B. So it cannot be in both A and B. Everything in A only that's unique to A. Nothing that has anything to do with B. Now B minus A is going to be the reverse. We want everything that's unique to B. It doesn't have anything to do with A. So any elements that are in A, you're taking them out. That's what B minus A is. This is telling us that in most cases, it's not going to be equal. Now, of course, you can do the empty set minus the empty set is going to equal the empty set minus the empty set. Sure. However, if you have anything in A or B, this is going to be true. A minus B is never going to equal B minus A. These are going to be mutually disjoint from each other. But we have this A intersect B. This third set is going to be pretty much the same thing. It's going to be mutually disjoint from these other two. And that's because of what they mean. We want everything in A but not in B. We want everything in B but not in A. And this one, we want everything that's in only A and B together. These three should never overlap when you have stuff in A and B. Here's a quick Venn diagram illustration to drive this point home even further. A minus B is going to be your stripes here. Notice that you're never going to bleed over into this. It's only an A, but nothing to do with B. Your B minus A is going to be the polka dots here. Notice that you're never going to bleed into anything here. You're just going to be in this B alone. Nothing over here. And of course, your A intersect B is going to be the middle part where we just have full on filled in, right? Full on filled in, but it never extends beyond this into the stripes or the polka dots. All three of these are going to be mutually disjoint sets. Now let's go back into some properties of our complements. Now we have the properties of complements. Now once again, if you need a refresher on complements, I have a video you can find right up here. Check it out before you come back to this, because if you don't know what a complement is, this is gonna seem very confusing. So check that out, come back, and then let's jump into these properties here. Our first one, it says A union the complement of A is going to be the universal set. A union the complement of A is going to be the universal set. Now remember, the complement of A is everything that's not in A. So if you have everything that is A, essentially A, and everything not in A, you have everything, right? You're not missing anything. You're unioning everything in A and everything that's outside of A. So you get everything, which results in that universal set. So that's why you have that U there. How about this second one? Here we have A intersect the complement of A. And this is saying that you're going to get the empty set. Now, it makes sense if you think about it. A and its complement have nothing in common. So when you intersect them, you're going to get nothing, the empty set. There's nothing in common with these two sets. So that's why you're left with the empty set here. How about this third one? This says the complement of a complement is going to be the set A. Now, if you take a step back and think about this, it also makes sense because you're going to say, what's not in a complement? Well, remember, a complement is everything not in A, right? So everything not in A is going to be everything outside of A, everything outside of A. However, you're taking the complement of that. So you don't want anything that's outside of A. That just leaves everything inside of A. So this double complement here essentially cancels out each other and you're left with just A. How about our fourth one? This tells you that the complement of the empty set is going to be the universal set. Take a step back and think about that for a second. The complement of the empty set, the complement of the set with nothing in it, is going to be the set with everything in it. It makes sense. The complement of the set with nothing, the opposite of nothing, is going to be everything. So that's how you're going to get the universal set. The complement of nothing is going to be everything. And by extension, the complement of everything is going to be nothing. If you look at the universal set that has everything, and you want to say everything that's not in that universal set, well, if it has everything, nothing's outside of it. So therefore, the complement of that universal set is going to be the empty set. So these are going to be the 5 easier properties of complements. These I found to be a little bit trickier, so I've already put their Venn diagram illustration here. But let's break them down. Number 6, it says we have A union B, and we're trying to find a complement of that. And we're saying that that's going to equal the complement of A intersect the complement of B. Now let's look at this Venn diagram and see what that means. So we have A union B. We know that's going to be pretty much this whole thing right here. And we're taking the complement of that. So you see I shaded outside of that A union B. We're leaving this untouched. That's what this first part tells us. Now let's look at this. A complement. That's going to be everything that's not in A. So that includes all of this, right? All of this B here and everything outside. The only thing that's going to be left blank is going to be this here, and this here. That's when you look at this A complement. How about B complement? Well, it's going to be the reverse. You're going to be looking at everything here and shading in everything on the outside. The only thing left blank is going to be this, and this. The thing that has B. We don't want anything that's in B, so you're leaving this blank. Well, what do those two have in common? Nothing in here, right? So it's going to be everything on the outside. They both are going to be shading the outside, so that's all that they have in common. A complement doesn't have anything in A, but it has this portion of B. But B complement doesn't have that portion of B. It does have some A, but that's not in A complement. So nothing in here gets shaded. The only thing that gets shaded is the outside. So this is going to be the same as this. And here's your Venn diagram illustration. Now for our last property. Notice I have two different colors here, and that's only to highlight what is not shaded. You may easily miss what's not shaded if I just had the one color, but with both of these, you see definitely what's not shaded. So let's jump in. We have A intersect B, and we want to find the complement of that, right? A intersect B, and we want to find the complement of that. Well, that's saying that's going to be A complement union B complement. Now, what does that even look like? Well, let's take this. Let's break this down. A intersect B. That's going to be this clean section right here. And we want to find everything that's not that. So you're going to highlight everything else. This is your set A over here. This is your set B. I've overwritten it because you're shading in everything but this little area here. That's what A intersect B complement looks like. So let's break this part down. We have A complement. That's going to be everything that's not in A. So once again, just like we did up here, we're going to shade everything, and we're going to shade this area here. We're going to leave this blank and leave this blank, just like we did up here. Leave this and leave that blank. We're going to shade everything else. All of this B here, except for this, all of this B here, and everything on the outside. Now we're going to look at this B complement, and we're going to do the same thing we did up here. We're going to shade this part of A and everything outside. This part of A and everything outside. But you're unioning them now. So, of course, you're going to get the outside, just like you did in the intersection. However, this portion that was in A complement and this portion that was in B complement is also going to be included. Notice both of those exclude this area here. So the only thing that's not shaded out of this entire picture is this section here. This section here. This intersection section there is the only thing that's not highlighted. This lets us know that in fact, A intersect B complement is going to be A complement union B complement. So I hope you were able to follow on today's properties. However, I want you to know that the goal of these properties is not to memorize all of them. The goal is to have a good enough understanding of the operations on sets that these properties make sense and that you can use them when you need them. But if you have any questions about what you saw today or even on homework, remember you can put it in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.